Hello, my dear children. Today's topic is system of particles and rotational motion. This is our topic today. So before that, I want to explain you about the syllabus. What are all the revised syllabus here? So the CBSE syllabus are given in this. So these are all the syllabus for CBSE. Actually, you can take, if you want, you can take a screenshot. It includes center of mass of a two-particle system, moment of conservation, center of mass motion, center of mass of a rigid body, center of mass of a uniform rod, moment of a force, torque, angular momentum, law of conservation of angular momentum, and its applications. Then, equilibrium of rigid bodies, rigid body rotation, and the equations of the rotational motion, comparison of linear and rotational motions. Moment of inertia, radius of gyration, values of moments of inertia for simple geometrical objects without any derivation. The derivation is not needed. Then I'll tell you about the NEET syllabus. This is the NEET syllabus for this year, 2025 recording. This is the NEET syllabus actually. So here also the center of mass of the two-particle system, rigid body, then basic concepts of rotational motion, moment of a force, torque, angular momentum, conservation of angular momentum, and its applications. Everything is there. The moment of inertia, radius of gyration, values of moment of inertia for simple geometrical objects, parallel and perpendicular axis realities, and their applications. Everything is there. Then equilibrium of rigid bodies, rigid body rotation, equilibrium of equations of rotational motion also there. Then comparison of linear and rotational motions. Okay. So, and then this is for JEE. Here also center of mass of the two-particle system, rigid body, basic concepts, all the same as like JEE main. So here, this one is NEET. This one is JEE main. Yeah. So all are here. Both are same. Okay. So we come to the syllabus now. So this is our syllabus. We are going to see. Okay. Okay, we'll see this system of particles. So first of all, we are going to see the center of mass. Okay. So here in your CBSE book, in your NCERT book, it is given as the center of mass for a two-particle system in 1D. Along x-axis means it is one-dimensional. I will explain you about the 2D also. So everything we are going to see. In this particular topic, we'll see. So here we'll see the center of mass. The center of mass actually, it is nothing but we are finding out the center of mass between any two particles. Here we are considering two-particle system for simplicity. We can extend this concept to the n number of particles in all dimensions, in 1D, 2D, and 3D. So first of all, you should have a clarity. that whether it is 1D or 2D or 3D. Okay, so that clarity you should have. And then you can connect this, it is a hypothetical mass where we can say at one point the whole mass is concentrated. So that is the idea. That is the center of gravity, we can say. Here we are considering a case, center of mass for two particle system along one direction. So you are taking x and y plane, but in this along x-axis alone, the particle is moving. So this is the first particle. First particle's mass is m1. It is in the distance. It is at the distance from the origin of x1. m2 is at the distance x2 at the origin. Okay. These two are at particular distance x1 and x2. And then its center of mass might be from at the middle. We can consider. So at the center, these two masses, m1 and m2, has the equal mass. That is the center of mass. It is concentrated at this particular point. That is x distance, capital X distance. So they are going to say how the center of mass can be defined here by means of a section formula. You have to use, this is a coordinate system. You know about the coordinate system. So coordinate system is nothing but you are connecting x-axis, y-axis, and z-axis through the points, right? You know how to plot the points. You have studied in a coordinate geometry about the distance between the 2 points. And then you have studied about the section formula. So we are going to use the section formula. Like m1, m2 be the ratio. So the distance only we are going to find out, right? So m1, m2 be the ratio. So like the distance formula we are creating. So this section formula, you have find out the section formula, right? Suppose if AB be the line and any point you are considering, which is sectionized the line in the ratio m is to n, then you will be getting mx2, this is x2 comma y2, this is x1 comma y1 point. If you want to find out that p of xy, this point, you are considering this point is internally or externally sectioning the line, given line segment. Okay, it is section the line segment. So we can say this point, right, according to the coordinate geometry, this point P of xy is the point which is sectioning the line AB in the ratio m is to n. So what is that? mx2 plus nx1 by m plus 1 n. This is x coordinate. Okay, and then y coordinate is my2 plus ny1 by m plus n. So as a whole, it is x comma y. If you solve all the points, and then you'll be getting 2 points of some x comma y, say 2 comma 3. Like that you'll be getting. So this is the point. This point, we are using the coordinate geometry to apply for finding the center of mass. Now the center of mass for one dimension, no. So it is taken as in the place of m and n ratio, it is m1 and m2, the mass we are taking. And then this is the x coordinate alone we are taking. Suppose if you write in the 2 dimension, then you can take y also. So y will be m2 x2, sorry, y2 plus m1 y1 by m plus n. So these 2 points should be taken. Okay. So if the 2 masses are equal, then you know it is the exact middle point, midpoint of 2 distances. So if the mass is same, so you can take the mass common and then you can take it for this. This is for 2 particles. In your book, it is clearly shown that 2 particles can be extended until n particle system. So if there are n number of particles, so don't confuse the children, students, you are confused always with the number of particle system as well as the system of n number of particles, as well as the 1D, 2D, and 3D. So alone x you are taking, then that is 1D. Okay, I mean y alone you are taking, that is 1D. Suppose if you are combining x and y, it is a plane. If you combine x, y, z, it is a space. Like that, you have to consider 1D, 2D, and 3D. This system can be, this formula, the center of mass can be extended until n number of particles. So, for n number of particles, you have to take For two particles, you took mx1 plus mx2 by m1 x1 like that, m2 x2 by m1 plus m2. For total system of n number of particles, it will extend until m1 mn xn divided by m1 plus m2 plus etc. until plus mn. So in short, we can write over the summation. So you can generalize the terms as I, where I is equal to 1 to n. So you can write summation over mi xi at the numerator, where I stands from 1 to n. In the denominator, summation over mi alone, where I stands for 1 to n. Okay. So all these summation over mi can be basically taken as a total mass of a particle. I mean, you are considering a lemma like one irregular shape or regular shape, whatever it might be, you are taking. In that, all the atoms also we can consider as a system of particles. Even molecular level also we can consider. If you consider, then it will be going to the continuous pattern. Okay. So, suppose if you are having a box of matchstick, all the number of matchsticks, right? So, suppose, for example, there are n number of matchsticks. That will be discrete numbers, 50 numbers or 100 numbers, like that. So, if you take the matchstick as a box, inside there are n number of matchsticks. That might be 50, 100, 70, like that. If you are having that particular system, then that is nothing but you have to take this formula. So total mass of all the matchsticks will be summation over mi, that can be written as capital M, like this. Taken an example, a matchbox with all the matchsticks. Okay. So the total matchbox weight is, the total mass is nothing but the individual mass of all the matchsticks. Okay. So you can consider three particle system also like this. As I've told you, it talks about the dimension. Okay. But the number of particles are entirely the mass, total mass it includes. Okay. So first you saw two particle system. Now it is three particle system. So x1, x2, x3, y1, y2, y3 it is extended. So two particles we can do, three particles we can do, four particles, until n particles we can do. And then if it is 1D, you have to take only one axis. If it is 2D, you have to take x comma y. If it is 3D, x comma y comma z. Okay. So take a note of all these things. Don't confuse with the dimensions as well as the number of particles. You can take an example. This is a matchbox consisting of all the number of matchsticks. Okay. Suppose, for example, if you are taking, you can write like this format also. This format also possible. Okay. So what is the x coordinate? This x, this capital x comma y comma z is the center of mass, right? So this capital X is the center of mass point. The center of mass can be defined as summation over mi xi, where I stands for 1 to n, and then summation over mi alone, where I stands for 1 to n, can be recorded as total mass. Okay. Same for y-axis, same for z-axis. Okay. You can write in this format also, where this is the total mass. Okay. Then, suppose if you consider two particle system. What is a two particle system in a plane? 2D. You are considering a 2D. I'm going to draw. Okay, vector axis. We can take vector axis. Okay. In the vector axis, along the x-axis, each and every unit is the unit vector I. Along the y-axis, in each and every unit is the unit vector j. Like that, you will be having j cap, I cap, like this it will be. So, in this, suppose if you are taking 3 dimension, then it is z. So, it is k cap. Okay, so each and every units, suppose I am considering one mass. So, one mass is locating here. Okay, this mass is named as, for example, this mass is some A. Okay, A particle. Okay, then What is the next mass? B particle. So the position vector of this particle is R1. The position vector of this particle is R2. Okay, where the center of mass lies in between. See, for example, the mass of the first particle is m1, the mass of the second particle is m2. Where the center of mass lies in between, you can better draw this diagram along with this video. Otherwise, you can't able to understand how it comes. Okay, then where the center of mass here, it might be here. This is the center of mass. We can indicate like the center of mass instead of writing center of mass in one sentence. You can write like the acronym CM or COM, like that you can write. So for this, what is the position vector? Here is the position vector. This position vector is capital R also you can use it, or CM also you can use it. Whatever it might be in your own way you can write. This is the center of mass position vector. Since it is a vector, all are in the vector realm, you have to represent that as a vector sign. In your book, vector sign is not indicated, but it is indicated as a block letter. You should write like this, like a vector arrowhead. Arrowhead, definitely you should inform. I mean, you should assign arrowheads on the vector sign in order to show it is vector quantity. So what is the vector? So R1, here it says the general, Ri care. You know that where I stands for 1 to n. Okay, if you substitute, copy this diagram so that I may just explain the other. Copy this. I hope you have copied. Okay, students. Then we'll move on to this. So if you put I is equal to 1, it will be x1 I cap plus xy1 j cap plus z1 k cap. So what is R2 here? So x2 like that. x2 I cap plus y2 j cap plus z2 k cap. So if you want to find the, so we saw the two particle system in a vector axis, right? So here one particle having mass m1, here another particle having mass m2, and this is the center of mass. Okay, center of mass, and these are all the position vectors R1, R1, RCM. This is R2 vector. So all are in vector realm. Then R1 and R2, what is how the resultant will be? RCM we can take, or capital R. So how it will be? You have to add these two vectors. R1 vector plus R2 vector. So if you add, then you can add the individual x1 plus x2 I cap plus y1 plus y2 j cap plus z1 plus z2 k cap. So like this, you will be taking, what is this x1 and x2? That is taken as capital X here, capital Xi. Then y1 plus y2 is capital Yj. Then z1 plus z2 is capital Zk cap. Okay. So we can take this as a position vector of the center of mass. Okay. So likewise, you can explain in terms of vector form also. So vector form is R is equal to summation over. We can write like this also. R vector is definitely, don't forget to put the arrowhead. Mi summation over mi Ri by m. So this is nothing but this is the summation over all the product of mass and the position vector. You can imagine, since you are taking a vector, it has these directions. So sometimes we can take from the origin we are taking. If you consider the center of mass, the summation over m1 and m2 will be like in the opposite direction. Okay. Summation over m1 and m2. Suppose if you are taking two particles, it is. You can take n number of particles, but the center of mass lies okay, in the center. We can say that means it denotes all the mass times the position vector will be the sum of all the mass times position vector will be 0. Okay, according to the coordinates you have chosen, either 2 coordinate or 3 coordinate, whatever it might be. Okay, these are all the equations you have to understand. All the summations and everything you should take. Okay, This, or you can write in this particular thing, the position vector or a position. I'll explain you first and then we'll move on to this. Suppose if you are taking this only, until this you can take some macroscopic. What is macroscopic? You know, I told you an example of matchbox containing matchsticks. Okay, that consists of definitely discrete number of matchsticks. Even then, it is bored enough for counting all the matchsticks inside. There is no copper, so but we can able to count the numbers. But if you are taking any particle, suppose if you are taking this mobile or anything, it consists of an atoms and molecules. If you want to count the atoms or molecules, definitely it will be in 1 centimeter of wire, you might have seen trillions and trillions of atoms. So it is impossible to count. So we can say this is continuous mass proportions. Okay? The mass is distributed continuously. That is what we can say. If you are going into a microscopical nature, microscopical realm, okay? So for that also we can able to write the center of mass coordinates. So for an x coordinate, for this we are differentiating. As I've already told you, what is differentiation? For a continuous system, suppose if you want to find the mass of a cloud, that is also possible, okay? You can break the cloud or you can differentiate the cloud into a small elements. Small elements like this, you are breaking. So small elements, that is known as delta M. We are taking a mass into a small elements until the cloud extends. Okay. And then you need to add all these things. So delta M1 plus delta M2 like that. You have to add, say for example, I, where I stands for 1 to n, summation over delta Mi. So this can be nothing but you can differentiate and then add all the differentiable quantities. That will be the integration, you know, right? Differentiation is nothing but for a continuous distribution of mass, we can calculate, we can break the mass into a smaller particle and then we can differentiate that. After differentiation, summation over all the differentiable quantities, that is the integration, will give you the result. So here also we are going to do with the same. So what is the x coordinate? That is the center of mass will be, this is the center of mass position for x. Summation over, instead of MIXI, you are writing delta MIXI. Instead of delta M, summation over MI, it is delta MI. So summation over delta Mi here also obviously it seems to be integration over dm, that is the total mass. Okay, total mass if you are taking into an atomic level or molecular level, it is the total mass. Then delta MIXI will be x into dm, integration over x into dm. As I told you, summation is possible only for the discrete elements, discrete number of quantities or discrete number of particles. Suppose if you are taking atomic level or molecular level, trillions and trillions of atoms are there. So we consider that as a continuous distribution. So inside, so how can you differentiate? You can differentiate and then addition is possible by integration format. So this is the integration format. Integration summation over delta M can be written as integration over dm, like this, small element. Okay, for x, y, z axis. So, and then you know delta Mi will be capital M. So you can resubstitute this from this equation, it shows, right? So it is the equivalent. And then in vector form also you can write in the place of x, y, z, is capital R cap or vector, and then in the place of small x, y, z, it is small r vector. You know that summation over the product of Mi into xi will be 0. If the numerator is 0, then all will be 0. So that is all given here. Okay. So we can able to calculate the center of mass for all the homogeneous bodies. Here the homogeneous bodies mean uniformly distributed mass. They are talking about. Okay. How the mass is uniformly distributed. For a regular shapes, we can able to find out all these geometric centers for the regular